All right, a flaming digital projectile. So this is like the best problem of all, right? And we're shooting from the top of a cliff, so it's going to be like, right, 62 degrees, so it's going to be like, that's 62, doesn't look big enough. 62, I should like practice with a protractor, 28.6. All right. And then the cliff is 24 meters tall. Is this height here, right? Okay. So first thing I'm going to do, I can't do anything until I turn this into a component vector. So let's do that. Right, and that's going to be 28.6 cos will give us the x, right? Okay, so let's do that. 28.6 cos 62. And that is 13.427 meters per second in the x direction. Okay, so let's see, what is it in the y? It's going to be more in the y, right? Okay, so 28.6 sine of 62. And that is 25.252 meters per second in the y direction. Okay. All right. Now we're good, right? I believe we know, of course we always know these guys, right? So that's 0, this is negative 9.81, right? But now we also know this guy and this guy, of course those always go hand in hand, right? We know this and we also know this. See if you can fill it in. All right, I'll fill it in for you. So let's see, 13.427, and this is the same, right? Once you know one of those, you know the other ones. It's the same velocity, right? This initially is 25.252. This will be something bigger than that, but down because it's going off a cliff, right? S is going to be down 24 meters. Right, so that's negative because it's down, right? Okay. And then to do this, I kind of just always do the same thing, right? So to find it, I'm going to do, to solve for t would be quadratic. So I'm going to find the v first, right? So in the vertical direction, let's do v squared is u squared plus 2as, right? So the absolute value of v is equal to the square root. Let's see, our initial velocity is 25.252. Plus, let's see, 2as, so 2 times negative 9.81. And then our s is down 24. The two negatives make that term positive. It's going to make the magnitude of this velocity bigger than the 25.252. All right, I can do this. Square root of that guy squared plus 2 times negative 9.81 times negative 24. And that's 33.295. So the absolute value of v is 33.295 meters per second, right? We choose, because we can choose, since it's going down when it hits there, right? Okay, we choose negative 33.29. Oh, it's not 295. It is 295. 33.295 meters per second. So this is negative 33.295, right? Because it's going down, right? Okay. And then we can find, we can use find time using this guy. V is u plus at. Right, so negative 33.295 equals 25.252 plus negative 9.81 times t. All right. Okay, so let's go. These guys, add them together, divide by 9.81. And the time in the air is is 5.9681. And then that, you can castle that across. All right, and then to find in the horizontal direction, we're just going to do S as UT. We'll find out if we're right here. U is 13.427. And then the T is 5.99681. Let's see if that works. Oops. Storage and T. I'm just storing things. I don't have my fancy TI-84. I'm slumming it with a TI-86 here. Okay, so let's see. Alpha A is 13.4 times alpha T, 80.1 meters. So I multiply these, that equals 80.1. All right, and then it says what's the speed of impact, right? So we need to figure that out, right? And that's going to be this guy here. So let's draw a picture of that. It's over and down. So this is 13.427. And this is 33.295. Right? And so I'm going to find the 13.427 squared plus 33.295 squared. Okay, so let's see, what is that? Okay, let's see if I've got that. Oh, I've got it all. Okay, so square root of, for me, it's just going to be a squared plus c squared. And I'm getting 35.9009 meters per second. All right. And then the other thing I might ask is what time is it in the air? The time in the air would be 5.97 seconds if you had to round it, right? As you would if you were reporting it as an answer. All right, so we've got, it goes 80.1 meters over. It's in the air for 5.97 seconds. It strikes the ground with a speed of 35.9. Notice it leaves the ground with that speed, but because it's gaining what? It's gaining kinetic energy from this potential energy or something, right? It's going faster when it hits the ground.